Namaste and welcome back to JEE Chemistry with Typical Monk. This is class 29, Organic Chemistry, Part 4, the reaction mechanisms. Now that you know the intermediates, watch them in action. A nucleophile can march straight in and knock a group out the back in one clean step, or it can wait for a carbocation to form first. A base can tear off a proton and a leaving group together, or in two stages. These are the substitution and elimination mechanisms, SN2 and SNI, E2 and E1, and each leaves a fingerprint, an inversion, a racemization, a particular alkene. Learn what the substrate, the reagent and the solvent prefer, and you can predict the product every time. Today, the four mechanisms, the energy profiles, and the rules that pick the path. One idea at a time. Here is what you will master today. First, substitution, SN1 and SN2. Second, elimination, E1 and E2. Third, the energy profiles. Fourth, what decides the path. And fifth, the stereochemistry and the key rules. One idea at a time. Let us set the foundation. Two families. Substitution replaces one group with another. Elimination removes two to form a double bond. Each has two paths, SN1 and SN2, E1 and E2. One or two steps. The one mechanisms go through a carbocation in two steps. The two mechanisms happen in a single step. Master line. The substrate, the reagent, and the solvent decide which path a reaction takes. Now look at the picture. The SN2 mechanism. SN2. It is a one-step, concerted mechanism. Bond making and bond breaking happen together. Backside attack. The nucleophile attacks from the side exactly opposite the leaving group. Inversion. The configuration inverts like an umbrella flipping in the wind. This is the Walden inversion. The rate. It is second order. It depends on both the substrate and the nucleophile, and it is favored by methyl and primary carbons. Now the two substitution paths side by side. SN2. One step, second order, a backside attack, inversion, favored by primary substrates. SN. Two steps, first order, through a carbocation, racemization, favored by tertiary substrates. And the nucleophile. A strong nucleophile favors N2. A weak one favors NN. The solvent. A polar aprotic solvent favors N2. A polar protic solvent favors NNN. Now the eliminations. Elimination. It removes a proton and a leaving group to form a double bond. E2. One step, second order. It needs a strong base and it needs anti-periplanar geometry. E1. Two steps, first order, through a carbocation. Just like SN1. Zaitsev's rule. The more substituted, more stable alkene is the major product. Huffman. A bulky base gives the less substituted alkene instead. Now look at the picture. The energy profiles. The SN2 profile. One step, one energy barrier, and no intermediate at all. The SN1 profile. Two steps, with a carbocation intermediate sitting in the valley between the two peaks. The slow step. In SNNI, forming the carbocation is the rate determining step, the taller of the two barriers. The SN1 rate. It is first order. It depends only on the substrate, and it is favored by tertiary carbons. Now, what actually chooses the mechanism? The substrate. Methyl and primary favor SN2, tertiary favors SNNA or EE via the reagent. A strong nucleophile drives SN2, a strong bulky base drives E2. The leaving group. A better leaving group speeds up all four mechanisms. The solvent. Polar aprotic favors N2 and E2. Polar protic favors NNE1. Temperature. A higher temperature favors elimination over substitution. Now, the stereochemical fingerprints. SN2. Complete inversion of configuration. The backside attack guarantees it. SN1 racemization. A mix of both configurations, formed through the planar carbocation. A2. Anti-periplanar. The hydrogen and the leaving group must lie opposite each other. Now match each clue to its mechanism. one step with inversion goes to SN2. A carbocation with racemization goes to SNI. A strong base, anti-pair planar, goes to E2. And the more substituted alkene goes to Zaitsev's rule. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. SN2 proceeds with inversion of configuration. Correct. Statement 2. SN-ein is second order. Wrong. It is first order. Statement 3. E2 needs antiperiplanar geometry. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the order of SNN1 in statement 2. Now, the 2 mistakes that quietly cost marks. The truth, SN2 is 1 step with inversion. SNN is 2 steps with racemization. The trap, calling SN unbiased sorted. In fact, it depends only on the substrate. The second truth, Zaitsev gives the more substituted alkene, while a bulky base gives Hofmann. The second trap, forgetting that a tertiary substrate cannot do SN2. It is simply too crowded for a backside attack. Now test yourself. Answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. The stereochemistry of SN2. Inversion. Question 2. The order of SN1. First order. Question 3. The rate determining step of SN-an. Forming the carbocation. Question 4. The major alkene by Zaitsev. The more substituted one. And question 5. What geometry does E2 need? Anti-periplanar. Let us gather it all in one breath. SN2, 1 step, inversion, favored by primary. SN1, 2 steps, a carbocation, racemization, favored by tertiary. E2, 1 step, a strong base, anti-periplanar, and E1, 2 steps, through a carbocation. Zaitsev gives the more substituted alkene. A bulky base gives Hofmann. The substrate, the reagent, the leaving group, and the solvent decide the path. Next class, the alkyl halides, their preparation and the named reactions. 4 parts, 1 logic. Every substitution and elimination comes down to a simple contest. Attack in 1 clean step, or pause to make a carbocation first. SN2 inverts the carbon in a single backside blow. SN2 flattens it into a cation and racemizes. E2 rips off a proton and a leaving group anti-periplanar, and E1 does the same in 2 stages. The substrate, the reagent, and the solvent quietly decide the winner, and Zaitsev picks the alkene. Read those clues, and the product is no longer a guess. Next class, the alkyl halides. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack G. I will see you in the next class.